Hey, y'all. Today we're going to start on Unit 3, and we're going to talk about, we've talked about uh, displaying data a lot so far this year, and now we're going to start talking about how do we collect the data that we want to display. So a few learning targets for you. So first of all, we need to know who we're getting information from, and there are two different types of groups that we'll talk about that we could get information from. The first would be the population. That would be the entire group we want to learn about. So, for example, if we want to learn something about the students at Unity Reed High School, the students at Unity Reed, that would every student would be the population. And anything we'd find out about that population, we would call a parameter. If we were to take a smaller group from our population, so let's say we take all the freshmen at Unity Reed, that would be a subset of the population, we would call that a sample. And any information we get from a sample, we call a statistic. What's really nice here is that population and parameter both have P's, and sample and statistic both have S's, so I find that makes it really easy to remember the difference. So let me give you an example. So if we find out a mean or a standard deviation about a population, that mean or standard deviation we would call a parameter. If we found that same information out but it came from a sample, that's something we would call a statistic. So the first way we're going to talk about collecting data would be through surveys. And so we survey because we want to learn something about a population. And so again, there are two ways that we can survey. We can either ask everyone in the population the survey questions, or we can get a sample, a smaller group from the population, and that's what we call a sample survey. So a census, like they were doing this year, is an attempt to get information from everyone in the entire population. If we're unable to do that, sometimes we're not able to do that because of time or money or feasibility, then we just take a sample survey. So we take a survey of a subset of our population. And it's usually a lot more efficient and cost effective and feasible to do a sample survey than it would be to do an entire census, because usually populations are very, very large and it would take a lot of effort to do a census. So some things about sampling. When we get a sample, we always want our sample to be random. I can't stress this enough. It has to be random. And some of the reasons why we want random samples are we want to protect against bias. So we don't want something about the people in our population, some characteristic that maybe some people in our population have, to either be overemphasized or underemphasized, overrepresented or underrepresented. So if we have a population, say, that has males and females, we would want to make sure that we didn't just get a whole bunch of uh, males in our sample, and maybe there's some difference about males and females in whatever we're asking, and so we want to make sure that we're going to protect against this bias. We want every individual in the population to have a fair chance of being selected. So when we do a random sample, everyone has the same chance of being sampled. And then we want our sample to represent our population. So we want all those characteristics to be represented in our sample that would be important to the population. And then what's important is sample size. So I have a pot of soup here and a bowl of soup, and this is not my creation. I borrowed these pictures. I also borrowed this sort of analogy from the book, but I think it works really well. So if we're making soup, uh, and we want to taste to see if the soup is seasoned well enough. First thing we'll do is we'll probably stir the soup up. And the reason we want to stir the soup up is because we want to distribute all of the seasoning and all of the ingredients throughout the soup. That's sort of like randomizing. That's sort of like getting a random sample. If we just sprinkle some salt on top of the soup and then we take a taste of the soup from the top, it's going to be really salty. But if we were to stir the soup, then the salt would distribute, the seasoning would distribute, and we could get a better idea of how the soup tastes if it's seasoned enough. And so when we talk about sample size, we need to have a nice large sample. Um, we need to have a nice large sample, usually, like 100 people or more. So we need a good sample size. But the sample size is not based off of how big the population is. And so this is why I have a pot of soup and a bowl of soup. So if I were to just be making soup for myself, I could take a spoonful of my bowl of soup and I could see how it tastes. All I would need is a spoonful to tell me if it needed some more seasoning. If I were trying to make a pot of soup for my entire class, the pot would be much bigger. But if I wanted to taste that soup to see if it was seasoned correctly, I wouldn't need to drink a bigger amount of soup. I could still use a regular spoon and taste it to see if it tasted right. So we do need a sufficient sample size. But if our population is much larger in one case than another, it doesn't mean that the sample size has to be equally as large. So I want to talk about some ways to sample, and you need to be able to decide the difference in these ways. So you need to be able to decide which way to use or which way was used. So the first is a simple random sample. In a simple random sample, we assign individuals numbers. So everybody in our population will get a number, and then we will randomly generate numbers. So, and we'll do this together in class, either using probably technology like the calculator. We can randomly generate a set of numbers, and we can sample the people who have those numbers assigned to them. Another way would be to stratify our samples. So we could group our population based on some characteristic that we would call strata. The easiest example for you would be if we were trying to figure out something about all the students at Unity Read, we could group them by their graduation year, so freshmen, sophomores, juniors, and seniors. We would call those strata, and then we would take a simple random sample within each strata. So I should say that sometimes we say SRS for simple random sample. So we would do an SRS in each strata, which is a group based on some characteristic, in this case, graduation year. So if we wanted to find out something about the students at Unity Read, and we wanted to make sure there was the same amount of freshmen, sophomores, juniors, and seniors, what we could do is we could assign numbers in each group, and we could take a simple random sample from each group. So maybe we would take a simple random sample of 50 students that are freshmen, 50 that are sophomores, 50 that are juniors, and 50 that are seniors, and then we would get a representative sample of our population. Um, Another way to do it would be to do a cluster sample. Cluster and stratified, I get confused a lot because they both have to do with groups. So if we were to try to sample in our school by using clusters, we could separate our population into homerooms. So what we would do is we would randomly sample clusters. So each room has a room number. So if we randomly generated room numbers, and let's say we randomly generated 5 room numbers, we would go to those 5 rooms, and we would take a census in that cluster. So we would sample everybody in that cluster. So I should say we should randomly select clusters. So we would randomly select clusters, and then we would sample everyone in those clusters. So in stratified, we have groups, and we take a random sample within every group. In a cluster sample, we randomly select clusters and then sample everyone in those clusters. So again, if we randomly selected 5 homerooms, everybody in that homeroom would get surveyed. A systematic sample is where we assign numbers, and then we would choose the, we'll say nth, I want to say choose every nth person. So nth means like 10th or 5th or 20th. So sort of like in a simple random sample, we would assign everybody a number. So in schools, we could use a student ID number. And then we could randomly produce one student ID number, choose that student, and then choose every 10th person from there. So every person who has a student ID that's 10 larger, and then 10 larger, and then 10 larger, and then 10 larger. And that would be called a systematic sample. And then a multi-state sample is when we combine any 2 or more of these sampling methods. So maybe we could stratify the school into freshmen, sophomores, juniors, and seniors, assuming, which we all know is not true, assuming that everybody in a homeroom is in the same grade level. We could then randomly select some clusters from the freshman homerooms and some clusters from the sophomores, juniors, and seniors, and then we could sample everybody in those homerooms. That may be not realistic because we know that we don't always have just freshmen, just sophomores, just juniors, and just seniors. So I do want to go through an example here with you. So I would say pause the video right now and read the example, and then we'll talk about the answers. So here we have 20 elementary schools, and the school board's talking about this testing policy that they're thinking about adopting, and the PTA is trying to survey the parents to see how they feel about it. And so here are 4 different scenarios on how they would survey, and so we're just going to identify which sampling method would happen. So the first one, they randomly select 5 elementary schools and they survey the parents of every student. So there were 20 to begin with. They randomly select 5 and then they survey everybody in those schools. That is what a cluster sample is. So each school is a cluster, and then they randomly select 5 clusters and survey everybody. They could randomly select 100 students from each elementary school and survey their parents. So they would consider each elementary school a strata. And so they want to get a sample from every single elementary school. And so they would do a random sample in each elementary school of 100. So this is a stratified sample. In the third one, they assign each student a number and randomly select 500 students from the school system. So if we took every elementary school student in the school system and assigned them a number and then randomly selected 500 students, that would be a simple random sample. So they would use some sort of number generator to generate 500 random numbers and then survey the parents of the students associated with those numbers. The last one, they would assign each student a number again, and then they would survey the parents of every 20th student. So we generate randomly one student number and then survey every student number that is 20 values higher. So that is called a systematic. I would have to say in this scenario, in my opinion, the best way to sample would be stratified. You know, like Prince William County is a very large county, and there are different characteristics about different areas in our county that are important. And so, if you take a sample from every elementary school, you are getting, you will be getting a survey from parents who live on the west side, the east side, and all the diversity of our county would be sort of represented within that survey. So that's all I have here. We're definitely going to talk more in class. We'll talk about generating random numbers. I'll answer questions. This is the first go at watching a video and then coming to class. So this will obviously improve as we continue. Um, I will have a question pop up here right at the end. It's real simple. Just answer the question and then you're done.